Okay, so let's get into the next section. So first thing that we want to do is identify some of these definitions. So this is one of the first times where I'm telling you you need to make sure you know what these four things mean. So first off, in systems of equations just means that we have two or more equations with the same variables. That means we have x and y in all the equations, or we might have x, y, and z. Eventually we learn three variable equations and things like that. And of course, if you move up in upper division math classes, you could even have more variables. What's important is that you can only solve a system if you have the same number of equations as you do variables. So if you have four variables, you need four equations. If you have three variables, you need three equations. If you have two variables, you need two equations, and so on. And what's important about that is the solution is where, for a two variable system, um, they would have to cross at one point for it to be um, the same. But we're going to talk about other um, potential possibilities as well. So, consistent means is that we have a system of equations where there's at least one answer. Okay, at least one answer, one point where they actually cross. Inconsistent means we have a system of equations where they never cross. So in that particular case, the slopes of the two equations would be the same, but the y-intercept would be different. Independent is a consistent system, so they have at least one ordered pair with exactly one solution. So if it's independent, the equations can only cross at one point, not multiple points, but only one point. And it'll make sense when we start looking at potential um, systems that involve parabolas and lines, or circles and lines, or things like that, so where they could cross multiple times. And then a dependent system just means that it's a consistent system, which means there's at least one answer. But in this case, there's actually an infinite number of solutions. So what dependent means is that the two lines are exactly the same, or the two graphs are exactly the same. So they share every single point. So that's the definition of all of those. Okay, so we want to make sure that we understand all those, because those are going to be some of the questions that you're going to see um, on the test. Okay, solutions of systems of equations. We have how is it represented on a graph? So notice here we take a look at it. So if we can graph a system, so notice y equals 2x minus 1. So remember, my minus 1 is my y-intercept. So we are going to draw a line. We are going to move this point to minus 1, because that's where it crosses the y-intercept. And then we can see here that it goes up 2 over 1. Okay, because it's 2 over 1, so up 2 to the right 1. So if we grab this one, we're going to go 1, 2, up, and over 1, and there's my first line. Okay, this one says negative x plus 5, so the plus 5 is where it comes in. I'm going to click on the line again. So we go over here to 5. That's where it crosses the y-axis. The negative tells me that I have a negative 1 over 1, so that means we're going to go down 1 and to the right 1. There's my other one. Notice how they cross right here. So they cross right at this point. So at that point is positive 1, 2, and then 1, 2, 3. So that would be my point there, is 2, comma 3 would be my answer. So that's where they cross. Okay, and I think they ask you, so at 2, my y value would be 3. Okay, well, actually, these are the different lines, and we're not worried about those lines. We're worried about the solution. So let me see what the exercises are before we go and do that. What do the ordered pairs represent? Let me see where they say where they cross. Is there an ordered pair solution that is a solution of both equations? Yes. So where they cross is at 2, comma 3. So that would be it. So state it. Are we sure we're done? Yes. And we're going to show the answer and see if it's correct. And yes, I should have put yes. So yes at 2 comma 3. So we can see that that is the answer. And what did you notice? So we don't have to worry about anything else. But what's important is the graph. What did you notice about the ordered pair from exercise 2? It's just the point where those two lines cross. Okay. So now we're going to do our own. Okay, so that's the first problem in the next one. So we can see that's, oh, actually, this is the first one, I think. Grab that. Oh, here we go. So we need to explain this first. So solving systems of equations in two variables by graphing just means, and I apologize, I didn't realize I had the TV on until just now. So solving systems of two equations in two variables by graphing. So a system of equations is a set of two or more equations with the same variables. It's consistent if it has one solution, inconsistent if it has no solutions. If it has exactly one solution, it's independent. And if it has an infinite number of solutions, it is dependent. So notice that a system can be consistent and independent, or it can be consistent and independent. Okay? A system can never be inconsistent and independent because it has no solutions, and it can never be inconsistent and dependent because that has multiple solutions. Okay, so knowing all that stuff, we can kind of figure it out. So let's go ahead and get these. I'm going to shrink this down a little bit. So, oops, didn't want to do that. Never mind. Okay, so here we go through and look at this. Get that out of there. Okay, so move the categories along to put their what they are. So we know that we have only one solution here, so therefore it is consistent and it is independent. This one is the same line for both of them. There's two lines here. It just represents the same line, so that means that it is independent and it has at least one solution, so it's consistent and it's dependent. Okay, so it's consistent and it's dependent for this one. This one, they're parallel, they never cross. So it is inconsistent because it has no solutions, and it cannot be either independent or dependent. Okay, so that's what we're looking at for those. Okay, so make sure that you are able to identify those and figure out what those are. Okay, okay, let's move on to the next one, and I think we're going to pretty much stop after this. So classifying the systems of equations. So notice here we have 8x plus 4y equals 22. If we solve for y, we're going to get y equals negative 1.5x plus 6. And if we solve for y on the second one, these don't look like the exact same equations. 3y, 6y, 6x plus 4y. Well, that's interesting. So it looks like they changed that equation there. So anyway, so let's mark this out. It's weird. So it should be 6x plus 4y equals 24. And let me just verify that. So if I divide everything by 4, yeah, that'll work. Okay, so this is the right equation here. So these are wrong. So anyway, so we have 6x plus 4y equals 24. It becomes this. Notice that my slope is negative 1.5. So they have different slopes, which means that they're going to cross. So they're going to cross, so it's going to be one solution, okay? And then the system is consistent and independent, okay? And why is that? Because it has one solution. So one solution means it's at least one solution means it's consistent, and exactly one solution means it's independent. Okay, so that's what we have for that one. Let's make sure that this one is right. Okay, so 10 plus 5, yeah. So if we solve for y, notice both of the equations have the same slope, but they have different y-intercepts, which means they are not the same line. So if they're not the same line, then that means they're parallel, which is what this is talking about. So we have no solution, and so the system is inconsistent. On the last one, we have 2y equals 6x minus 14. That's what we have. We have 3x minus y equals 7. And in this case, we have the exact same equation for both of them, so therefore it has infinitely many. So it's consistent because it has at least one, and dependent means it has an infinite number. So it's got to be infinite. Okay, and at that point I'm going to stop, and then we're going to do another video from here.